Alright, in the last video we talked about vectors in terms of their components. So in 2-dimension, A could be written as A1, A2, and in 3-dimension it can be written as A1, A2, A3. Alright, well, a unit vector is a vector with magnitude 1. Okay? So it doesn't matter what direction it's in, as long as it has magnitude 1, it is called a unit vector. So if A isn't already a unit vector, we can get a unit vector in the same direction as A by taking A and dividing by its magnitude. So our scalar factor is going to be 1 over the magnitude of A. And that's easily verified that the magnitude of this new vector is indeed 1, which makes it a unit vector. Alright, we have 3 really important unit vectors. And the one that travels along the x-axis, we call that one I. And in 3 space, that is 1, 0, 0. Along the y-axis, we call j. And that is 0, 1, 0 in 3 space. And then along the z-axis, we call k. And that is 0, 0, 1. So these are actually called our standard unit vectors. And any vector that we have, A equals to A1, A2, A3, we can write that as the sum of our unit vectors. It would be the same thing as A times 1, 0, 0. I'm sorry, A1, A2 times 0, 1, 0 plus A3 times 0, 0, 1. Or A1I plus A2J plus A3K. And that's pretty neat. That'll come up a lot with us. And the last thing I want to talk about before we move on to the dot product is adding vectors component-wise. So we already talked about how we would add them geometrically. So if we wanted to add the vector B to the vector A, this is A right here, and we have a vector B right here, the way we would add it is we would pick up B, place its tail at the head of A, and we'd construct our new vector, and that is A plus B. Well, we can actually find this component-wise by taking the components of A and we add them to the components of B. And that gives us A1 plus B1, A2 plus B2. That is, the components of our new vector is the sum of the components of our vectors A and B. And I leave it up to you as an exercise to show geometrically while this behavior leads to that algebra.